Hi, my name is Kyle, and my partner Liz and I chose to test vinegar as our pollutant to determine if it would encourage germination or hinder it. Vinegar has many uses from flavoring food to cleaning. While most varieties of vinegar are made from natural sources, processing vinegar often involves chemicals derived from petroleum. Vinegar can be toxic to the environment, especially aquatic life, due to its acidity. After learning this information, we determined our hypothesis to be that vinegar will dissolve the seeds and there will be no germination. We used a variety of materials to conduct our experiment. The list included graduated cylinders, paper towels, vinegar, distilled water, permanent markers, a scale, 4 petri dishes, radish seeds, and a beaker. Step 1. Gather 4 petri dishes and label them 0%, 1%, 2%, and 3%. Step 2. Place 5 seeds on a sheet of paper towel, wrap the seeds in the paper towel and place it in the petri dish. Step 3. Add 20 milliliters of water into the 0% petri dish. Step 4. Measure out 100 milliliters of water in the graduated cylinder into the beaker. Step 5. Measure out 30 grams of vinegar and pour into the 100 milliliters of water. Step 6. Place 5 seeds on a sheet of paper towel. Wrap the seeds in the paper towel and place it in the 1% petri dish. Step 7. Add 10 milliliters of water and vinegar combination into the petri dish. Repeat steps 6 and 7 with petri dish 2% and 3%. The control we used for this experiment was a 0% solution containing only distilled water. Additional controls we utilized included controlling the size of the paper towel, the temperature of the environment the samples were stored in, and the amount of light they received. We tested 3 vinegar solutions with concentration of 1%, 2%, and 3%. During day 1 of the experiment, we did not notice any changes in any of the petri dishes. Day 2, the petri dishes containing the concentration with vinegar seemed lighter in color and more fragile. As we moved into day 3, we started to see some germination in the controlled solution with 2 seeds germinating. Day 4 showed more germination in the controlled solution with 2 more seeds starting to germinate. On the final day, day 5, we noticed that in the vinegar concentrations, some of the seeds were starting to lose their top layers of skin, and none of the solutions containing vinegar showed any signs of germination, while in our controlled solution we saw 4 seeds germinate. Our results aligned with our hypothesis because although we did not see the seeds fully dissolve due to the vinegar, we did see many of the seeds in the concentrations containing vinegar starting to break down by losing their color and layers of their outer skin. Our experiment also supported our hypothesis because, as you can see in the picture, none of the concentrations containing vinegar showed any signs of germination. Our bar chart depicts the outcome of the experiment, echoing our results mentioned previously that none of the vinegar concentrations produced any germination while our control solution of distilled water germinated 4 seeds over the course of the 5 days. The data table displayed shows that while 80% of the controlled solution germinated, 0% of the solutions containing vinegar showed any germination. While researching this experiment, we were surprised to learn that many gardeners and farmers turn to vinegar as a natural herbicide to combat weeds. Some potential next steps could be reducing the amount of vinegar to determine if there is a level of vinegar exposure that is sustainable for plant growth.